So in previous section, we learned a high level overview of Docker, right? How the Docker works. That's a high level, okay? When we go to the lab, you will learn more about the Docker technologies and the tools, commands, all things. So today I will briefly explain the Kubernetes, okay?
Okay.
So all of you, any idea about Kubernetes?
It orchestrates the containers.
It
How
is
it's
a plan.
We learned containers, right? How to create a container.
Yeah,
Yes.
Yes.
Kubernetes orchestrates many containers
it's a
distributed
platform.
across.
Okay.
It's a platform to which contain containers, which is to manage containers, different containers.
Okay. It's a platform. Yeah, we can say it's a platform, but the perfectly we can say it's a orchestrator. Okay. It's a orchestrator to orchestrate or manage containers, run containers, build containers, and manage containers. Then, yeah, load balancing containers, health check containers. So many responsibilities that take on Kubernetes. Okay. So basically, Kubernetes is a container orchestration tool.
Orchestration means
Orchestration means it will manage all the things. I mean, all the microservices like different containers managing.
Like synchronize the different things.
okay.
You know how the conductor in the orchestra plays all the instruments. Now the
Yes.
violins will play. Now the clarinet will play.
Who is
Like
who is
who is playing
managing?
loud, who is playing south, right? This is the container, the conductor in the orchestra, basically.
Sequencing the things which will come first, like that.
All types of details of control, right? Like how many containers are deployed, where are they? Like every little detail like that to orchestrate.
Okay.
So these are the questions. Okay, why we use Kubernetes and what is Kubernetes? So I will give some example. Okay. So Kubernetes is a container orchestration. So nowadays, mostly software application or softwares are running in microservices. Okay. What is microservices?
Localized container with the service installed.
No, I'm microservices. Yes. Heard about microservices, right?
Yes.
All of you?
Like the
Any
Java
idea?
microservices.
Any example?
Java microservices.
I mean,
APIs are like different
no.
APIs.
Before jumping into microservices, there is the traditional way is something called monolith. Monolith. LITH. Monolith services. This is a traditional way of software. It's a kind of technology. Okay, for example, we have or there's a software team. Okay, so the software team, their main agenda will creating software, right? So they will write up the code. Okay, they will write the code, write code. Then they send the code to some repository, right? Before that, they will test the entire application, their local machine. Then everything's fine. They will send the code to any repository. Okay. That's the scenario the developers follow. So coming to monolith services, consider there is an application. Okay. That application using the monolith service. How I mean, that is, for example, it's a Flipkart. Okay. Flipkart. This is an application. So this is a beginning, okay, beginning stage of developing Flipkart application. So they are using monolith. Okay, I will explain with the monolith. So they will choose only a single language for developing the Flipkart application that they will design, or we can use Python, or we can use Java, or any other language. Okay, consider they are using Java to build Flipkart application using which service? Monolith service. So monolith service, there is an architecture for monolith. Consider this is the main application. Okay, main application in the sense of consider this is the front end. Okay, Flipkart front end page. I mean, when we're typing flipkart.com, we are entering to this page. This is front end. The front end is wrought up with the Java. Okay, and there is a backend, right? Backend is actually it's attaching with the front end. Okay, like coming to monolith. So backend also with the Java, because coming to monolith service, if we choose monolith, we only use a single language. Okay, we can't using different language for different services. These are services. Okay, these are considered. This is first services. So this is second, and then this is considered as leave this thing. Okay, there's no space. That's why I'm consider this is checkout. Okay, checkout page. This also wrought up with the Java application. Okay, then there are different services there, right? When we clicking different page, different services are there. Like this is cart, Flipkart cart. Okay, what are things we choose? Okay, that all things will be here. So this also using Java. So consider like there are different services. All services are like this. All are attached with the main services. The problem here is, okay, for example, if any services is facing any issues, like for example, the cart issue, some issues. So it's difficult to find.
Your voice is breaking up. Can you repeat everything you said?
Now it's okay.
We still don't have your voice.
Now it's stable, right?
Yes, sir.
Okay.
Yes, now it's stable.
I placed my phone better place. Okay. Yes.
So all these microservices have to work together, is what you were saying.
Yes. Not microservices. I'm talking now the monolith. Okay.
Okay, I think you were drawing something about the microservices when your transmission got cut, I think. So we didn't hear that part.
Yeah, this is monolith. Okay. Monolith. This is monolith services. So this will be the front end. This will be the front end. And this will back end. Any other services like application cart, checkout page, then this will be some
Cart.
APIs. Consider we can using some APIs. So these are the services that integrate or interrelate with each one. Okay. So this is a traditional way of application. I mean, software development. So the problems may be, for example, this is considered this is in production. Okay. So some application or some services will have some problem. For example, this checkout page have some issues. So what will we do? We need to alter the entire, I mean, using the entire code, right? Because all applications are integrated, right? Not in the sense of integration, I mean, all the applications are working
Together.
yes, and all the applications code are same. Java. This is example, okay, Java. So any of the application is down or consider, or if down, and another scenario, for example, the requirement is we need to alternate or we need to add some new features for some checkout page, okay, because checkout page is now some other format or design, so they will alter the things, okay, so they need to use the entire application for that scenario because all are connected with each other. So that's some disadvantage of the monolith application. This is not so many other problems. For example, they are starting with Java, right? So they can't change this language to any other because that's the main problem or main disadvantages of monolith application. Then, yeah, these are the high level overview of monolith application. Okay. And this monolith application, we are not using any microservices. Okay. This is a traditional way. So coming to microservices, consider the same Java application. Okay. Sorry. The Flipkart application, how to build in microservices using microservice technology. So this is the front end. This is back end. Checkout page, cart, any other services like consider there are different services. Okay. So this is called microservices. So there is no direct connection with each other. And the main advantage here is, for example, we are using Angular for the front end. This is our front end. We can use Angular language, okay, for building the front end page. For back end, we can use Java. Here Python. We can use here different language for different services. For checkout page, they are using another language like PHP or anything, then this is the way how the microservices running. And coming to our containerization, it belongs to, for example, the front-end application is running in a container. This is running in another container. Each services are considered each containers. For example, we can choose example of Netflix. Latest application, all applications are running in container, okay? Netflix. So these Netflix have, I think, around 8,800 of containers there, in my belief. So that much containers are for a single application. For here, for example, is this front end needs to upgrade, okay, or that any new features added. So it's easy. Only the front end developer will go to the corresponding container or corresponding code, okay, not container, corresponding code, and update the latest features, okay. Then we can push to the new code to the corresponding container. That is not affected to any other container. Got it? If any any services is making some issues, for example, the backend have some issues, okay. When coming to monolith, if any services issue, then we need to stop down the entire application. So coming to here, we only manage the corresponding backend container. All other services are running at that time, even this in the maintenance stage.
So microservices means it's related to container. All the separate services are running in a separate container.
Yes.
Microservices is like architecture. So different languages can be doing some defined parts, right? And then,
Yes. For example, we
but
need
each
to
one will
connect.
be in a separate container that talks to another container through a network of containers.
Yes, these containers are basically interconnected. Okay, for example, first we need to log in. This is considered, this is a Flipkart page. Okay, or this is a Netflix application. Okay, consider. So the users accessing the front end page, right? First they hitting to the front end page. Then we need to log in, right? After login, we will get a database of films, right? So it will route to other page. This is considered. This is a index page or where the movie is listed, okay. So each containers are connected via APIs, okay. Using APIs they can connect, or we using these containers are in the same network, okay. So these containers are interrelated. So we go to streaming movie, okay. Here we need to select the movie, then we just routing to the streaming area, like this is streaming. So here we can see the movie like that using this data, movie data.
Got it, sir.
How are these services connected? What is they are like data pipes, or
Pipes means?
like is it a network connection, or is
Yes.
it like a pipes?
Yes. That is network.
So it's a virtual network.
Yes, right. Virtual network. Logical network.
Logical network. So is that like a VPC?
No, not VPC
No.
actually.
VPC is actually simulated virtual computers, but this is like a logical network of.
This is actually nothing. For example, there is coming to Docker, we will create a Docker network. So we will get the local IPs like 192, similar like IPs we will get. So inside the network, okay, we create a network, Docker network. So inside the network, we will create containers. So that all the containers are under the same network. If we didn't create a network, then it will go to the default network. That's the scenario. In coming to production environment, we will create different networks and connectivity, all the things we need to check.
I think with lab it will be much clear when we'll do the lab. Yeah.
Yes, okay. So you will get media, right? Monolith and microservices.
Yes, sir.
We can nowadays we can choose monolith, no problem. But first we need to study the applications, feasibility, all the things. After that, we need to choose the corresponding strategy, like if it's got to the monolith or microservices. But yeah, microservices is much complex when coming to monolith, but this is a good way to deploy application like complex applications. Not this
So,
service. I told like this
uh,
8 lakh.
one question, sir. Application has many sub applications. So, is it like each sub application can be a microservice or it works independently?
Yes,
Okay.
each services are here. I mean, works independently, right?
It is in a vast level. Like front end is a big part, the database is a big part, but under front end there are many features that works independently. So for that also, like it will use different container. Is it like that?
No. For keeping the front end, we will create a container for front end. Front end means, I mean, the page first we landing, okay, for a website, for example. The
Yes, yes,
landing
yes,
page of a website is considered as a front end.
yes.
From there, we clicking some other sublinks or any other services like we will get a subdomains like switching different services. Subdomain, for example, google.com. That's the main front end page. Then Google slash checkout.com, like that is another services.
Right, right. Every page it belongs to front end only because the user what sees that is front end, right?
Hmm. No.
It's not only the login
Not all
page.
the pages that the user sees not front end actually. I mean the landing page,
Right, right,
because the checkout page also user see, right?
right, right.
And the payment gateway using payment page also seen, right? When that's coming to application, the payment is running in different application, different services actually.
Mm-hmm.
Got it?
Yes, sir.
Or confused?
No, no, I got it. That payment page, the page what we developed, that is by you, that is also front end part of front end, but
Consider
the
this is a
data
front
what
end.
we got.
Consider this is front end page, okay? So for the front end page, some codes, right? Code, they need to write some code, right? To viewing content like that. Then they will click some link or anything. They need to direct to another page. Consider this
Right.
is Flipkart page, okay? Flipkart landing page. So they are listing some uh, products there. Okay. Then here we click some product, okay? It will go to another page. That belongs to same page, I think. I mean the front end. Then they will buying the product, right? Or they will choose the product in their cart, okay? So clicking, I mean choosing cart, then it will go to cart. That is another services. This is cart. You can see when going with the URL, you can see there is a forward slash cart.
Right, right.
Yeah. So this is another services. We can wrap up all the services in a single, directly pointing to the front end page, but the problem here is there are too much codes there, right? For this page also code, this page also code. So the code will huge. Now the coming to microservice, we divide the code, right? Divide each
Right.
code and we keep that. This is the first service, this is second service, and this is third service. Each services belongs to a different container. So any problem here happen? For example, two, they only looking for the second services code. Uh, Whether they looking the ender code, okay? Got it.
Yes, sir. It's clear only.
Any other doubt?
What was
We
the thing where you drew the 1, 2, 3, the diagonal lines, and
I
one
mean
will call
that
2,
that
2
that
will call 3, like that?
that's a simple scenario. Like for example, I am that just to illustrate the code. Okay, for example, we have a full uh, application code here. Okay, so how we choose? I will divide the code with the services. For example, like this, I'm just wrote that thing. For this is the front end code. Okay.
One is front end.
Yes, this is back end or this is card like that. So each services have codes, right? Code. The developer writes the code, right?
Yes.
Consider each are in a single page. Okay. So there are too much code, right? So the
Yes.
developers manage this code, and if any issue or error, any bug they face, what will do? They need to review the entire code. That's why they are keeping different pages or services. Like front end, this is another service two, service one, service two, service three, like that.
Yeah, they created component for each services, and
Yes.
that
This is
component,
just an example. That's all, Amar.
right?
Leave it. Shilpa, are you okay?
Yeah,
Or any confusion?
no. I there are certain services which we use in our production tools, so I am able to connect.
Okay. So, mm, so yeah, our topic is Docker. Sorry, container. Okay. So,
Kubernetes.
sorry, yeah, Kubernetes. So I will explain the Kubernetes architecture. Okay. Okay, so we will explain different components, the architecture components are related to Kubernetes. Okay, so Kubernetes is actually I mean, there are some components and services inside Kubernetes, and we use some virtual machines to create Kubernetes actually. Okay, so Kubernetes have some architecture actually. So we will go to the architecture. There are two parts for, have Kubernetes. Okay, two parts for a Kubernetes. The first part is master. We can say master plane. So this is a master plane. And this is the worker plane. Or the part, okay. So coming to master part, there are different components are there. Not different actually, if there are four components. The first one is API server. ETCD. Controller. Scheduler. Then coming to worker part. Here there are workers, okay. We can choose how many workers here that as per the requirement. Okay, this is the worker part. And inside the worker part, these are the workers. Okay. So coming to worker parts, the workers are actually virtual machines. Okay. So we can say this is a VM, virtual machine. This is also a VM. So in this worker plane, we have two VM. Example, EC2. Example is we can choose EC2 micro or medium, anything, okay? Micro or medium. You can choose as per our requirement, okay? Same here, okay? And yes, two more components here, like inside the virtual machine, we will create containers actually, okay? So this is the high level overview of Kubernetes architecture. And coming to Kubernetes, there are two parts. One is master part and the next one is worker part, okay? And in master part, there are some components like API server, etcd, controller, and scheduler. So what is API server? What is ECTD? Container like scheduler. So before that, for example, we deploy or we install Kubernetes, okay, for deploying some application or integrating that Kubernetes with any CI/CD pipeline, okay. So consider we successfully installing or configuring Kubernetes. So how we use, how we remotely accessing our Kubernetes cluster. Yeah, one more thing I miss. This is called actually Kubernetes cluster, okay. The name is Kubernetes cluster. Okay. This is actually cluster, the entire cluster with the master part and worker part. Part. So, okay, we successfully install the Kubernetes and all the things. So, remotely we need to access our cluster, right? So, how we will access using the API? Okay, for example, I have a laptop here, a remote user. I am a remote user. So, my laptop is this. So I can use some commands. There are some Kubernetes commands we need to learn. Okay. So using the command, we can directly connect with our API server. First, we accessing through API. Okay. The API server is nothing. How remotely accessing our cluster using API server. So there is a command for Kubernetes like kubectl and some plugins we need to install in our local machine or the laptop to access our Kubernetes cluster. So first hitting to API server, okay. Then we can do our activities. Like for example, we need to viewing our virtual machines, our give me some minutes. I will add more thing. So coming to virtual machine, okay, coming to EC2 machine, in our Kubernetes cluster, we choose two machines, okay, we can add more like 3, 4, 5, 6 like that as per the requirement. So how we will containerize our application inside Kubernetes using this way, okay. First, we need to create a pod inside a, this is actually called node. In Kubernetes, the virtual machines, how we notify like node and node, okay. So in this case, we have two nodes. Okay, this is the first node and this is the second node. node 2. So the next thing is pod. Pod. So here inside node, in this example, we have two pod. This is the first pod, and this is the second pod. Similar way, the second node have same one node, one pod, and pod 2. Okay. So inside the pod, we will create container. This is our container. Container 1. Similar way, here we create another container. Container 2. Inside the container, the application. Confused or clear? All of you?
I think it will take time to digest this. It's a
Yes.
lot of
That,
it's a pretty involved subject, I think.
yes. It's nothing actually. We will take a virtual machine. Okay. EC2 virtual machine like T2 medium, T2 large or anything. So inside and we called as node. Okay. The virtual machine we called as node in Kubernetes. So we have one node. So our requirement is to deploy application inside container. So we can't directly deploy container into the node where we are in Kubernetes, because the Kubernetes master can't directly access to the what container. Okay, there is no rule or anything to directly accessing our container. That's why here we create another thing called pod. Okay, so the worker part. Okay, what are the things in worker parts fully managed by who? The master part of the Kubernetes. For example, the machine health check node, the pod health check, container health check, all things managed by the master part. Okay, so there is a request from the user or the admin. I mean, they are connecting with our Kubernetes cluster and asking to the API server. I need to know how many pods are running in the Kubernetes cluster or how many containers are running. Application, viewing application, editing application, all things happen using this way. Like this is a remote connection. Okay, remotely accessing the API, then go to check the worker part and all the things. Before that, I missed two things. I will add that thing. Coming to I didn't explain this node, okay, because there is no space. Here I will take that thing. Each node, okay, coming to each node in Kubernetes have two more part, like that part belongs inside our node actually, okay. For example, when we are creating the EC2 machine, that two parts inside the virtual machine. That is called these two things are a components like this, okay. But these two things inside the virtual machine, each virtual machine. The name is kubelet, LET, and this is called kubeproxy. Okay. Kubelet is a service. Before that, I will explain this service. Okay. So API is for connectivity outside the cluster, and it will interact with our bucket part. Okay, what are things? All the things knows. The API is the main part in master part. This is it. Then coming to etcd, this is a small size key value pair database actually. So why we using database in Kubernetes means the Kubernetes master part knows what are the list of pods container, node, all the things will be listed here in this database. Okay. So when we configuring all the things, the database knows all. The etcd services knows how many nodes are here, like node count. So here 2 node, right? So it will fetch here in etcd, like in this cluster we have 2 node. Then how many ports are here? This is port 1, 2, and here 3, 4. So that will fetch here 3 ports. Then the container, there are several containers like that. All the related things are saved in the etcd. So the user asking to the API, how many nodes are here? So the API directly fetch the data from the etcd and give back to the user. These were the how we have 2 node, and the node name, node network, that some related details will send API server and back to the requester. This may be the Kubernetes admin or anything like that, or DevOps engineer who are accessing via the API is the admin, mostly the admins actually. Okay. Then coming to controller. Controller is actually controlling the workflow, okay, the workflow of Kubernetes. So the controller knows what are the things we need to do. As a master part, what are the things need to do to create resources in worker part. The resources means, for example, an application deployment. Okay, so the application, for example, consider there is no application. Okay, if there is no application after we successfully configuring the Kubernetes, there is we didn't it's deploy an application. Okay, then it's plain actually. There is no pod and no container, only the node there. Okay, so how we deploy application? Same way. First we need to connect with the API server. Okay, we have a template or a YAML file. So inside the file, similar like the Docker file. Okay, inside the file, we need to define all the things: the application code, how many ports we need, how many container we need, all the things we need to brought up in a YAML template. Then we will push the YAML to the API server. So the API server will send through the controller, and controller will manage the workflow. Then going to the scheduler. The last one is scheduler. Scheduler is like a queue system actually. For example, yeah, schedulers knows that the available resources here. Okay, the node 2 is available. Okay, so there is before there is one deployment happen here, so that deployment goes to the node 1. So node 2 is healthy and available, so much resources there. That's the main thing. So the scheduler knows, the scheduler will queuing the next application pushing from the user. So scheduler will schedule the task to the corresponding node. And this master part we didn't configure actually. When we deploying, configuring or installing Kubernetes, the master part is installed by the corresponding provider. There are 2 ways we can deploy Kubernetes. And before that, there is 2 components there, kubelet. So the coming to each node, okay, these 2 components are there. In here also there, like kubelet and kubeproxy. So the kubelet works for integrating, there is a connectivity to the API server. So they are communicate regularly, periodically, for checking the status of the node and the resources, how many resources are currently utilization, how many free space are there, all things connecting through the kubelet actually. This is like a agent. Consider this is an agent. That agent installed in our virtual machine. Then the queue proxy is this is a networking thing. To this way we accessing our application. Okay, for example, here this is a pod. Okay, inside the pod there is a container, and this is the application. So the application must view, right? So the access through the application via queue proxy. Then go to this way the access happen. For example, any user accessing the application. So this is a connectivity. The connection go through the queue proxy. So this is the high level overview of Kubernetes. Then we can, two-way we can configure Kubernetes. The first way is manage Kubernetes. Then self-hosted Kubernetes. Managed Kubernetes is this is managed by our cloud provider. For example, AWS. AWS have managed Kubernetes services name EKS, Elastic Kubernetes Services. Azure have the same. What's the name? AKS, Azure Kubernetes Service. Then GCP, Google. So Google have their own managed Kubernetes, GKE, Google Kubernetes Engine. Okay, so we can use these managed Kubernetes as per our requirement. This is easy, okay, comparing to self-hosted, this is purely easy. So we can go with the case, then go to the dashboard and give the name and how many nodes we need in our Kubernetes cluster. All the things we can uh, predefine and set all the things. Then we can simply launch the EKS. After that, we will get the Kubernetes cluster. Then we can deploy our application inside the Kubernetes cluster. Same way in AKS and GKE. The self-hosted means from scratch, we need to create the full entire Kubernetes cluster using similar way, like how to go with the Kubernetes cluster as per the requirement. For example, we need to deploy Kubernetes in self-hosted means first we need to go with the Amazon, then we will deploy two machine, okay, two machine or three machine. Consider we deploy three machine, EC2 machine, okay, T2 medium or TT large, anything, and we will installing the components like the master part components in the first machine, the etcd, API server, and all the things. So, and we will make this as master part. And these two are the worker part. Create two machine like node 1 and node 2. This is when comparing to manage, this is a time taken process and we need to install the components, all the things.
Sir, one question.
Hmm.
In the earlier Kubernetes architecture diagram, the master part that component is also VM because you
No,
didn't
no, no, no,
define
no,
like
no, no, not VM actually. This,
because only VM is this worker plane, right? These are
yes,
instances
yes,
VM,
yes, yes.
not the master. But in the current diagram, you said like master. So what is that one? V.
Yes, actually, these are the services, okay? These are the services. These services are predefined actually. For example, predefined, and when we, for example, we are going with the managed Kubernetes, okay? Managed Kubernetes, the AWS will manage the deployment of these services. These are the small services, but we can see these services are running in a container. Got it.
Yeah, can you move to the next diagram what you are explaining? In that actually you said VM, that's why I got confused. Okay, master, like this also you said like master instance, right?
Yes.
Yes. But
Yes.
in the
Here,
previous
we will take one machine for master. And inside the machine, that container is running. For example, etcd, API server, all things related to here. That components belongs to this master part. Okay. Then coming to the this part, like self-hosted, the same services inside our cluster actually. How we can see this like API server, etcd, we can see the our containers like API container. This is actually a small size services. Okay, consider this as small services to working with the other services, like other services in the sense of nodes and all the things. When we go with the lab, you will get more idea how this works. And
okay, okay. But this the services must be running inside some machine, right? Some VM
yes,
instance.
yes, yes, yeah. Here you will confuse, right? In coming to manage server, manage Kubernetes, we will keep one machine for master like that, right?
Right.
Yes. This is for self-hosted because we building these all the things like from the master from scratch. We are the one who need to manage all the things, and this
Mm-hmm.
is purely managed Kubernetes services. This is so these parts will be configured by the cloud provider. That's why we called as managed Kubernetes service.
Right.
Okay,
Okay.
have any confusion?
Yeah, I got it. This is also instance, but anyways, we are not doing anything. It is already predefined. We just use it.
Yes, yes,
But the workup part, we are going to configure it.
right, right, right. We need to install all the things like the
Right.
master components. We need to choose one machine for the master and all the things. Okay.
Okay.
And I have one script for creating a self-hosted Kubernetes machine, but I don't know it's depreciated or not. I will check. Okay. If yes, we can try both self-hosted and managed. For managed, it's easy with the commands. If you have time,
So
then
now
I command. Yeah.
nowadays, which is mostly preferred in industries, the managed one.
Manage one.
Okay.
Only manage one. Yeah. When you go through the JDs, okay, interview JDs for DevOps, you can see like AKS, EKS. You didn't mention, right? If the name is EKS, that we can say that is self-host. Sorry, that is managed Kubernetes because it's managed by
AWS.
yes that managed service name called these names EKS, AKS, and GKE. These services are managed by this cloud provider. Otherwise, we can directly say it's a Kubernetes, not E or A or G, right in front of the Kubernetes.
Okay. Okay.
And we
Okay.
called Kubernetes a short way like a, K8s. This is a short name of Kubernetes. Okay, K8s. That means Kubernetes. So inside the K and S, there is 8 alphabet. 1, 2, 3, 4, 5, 6, 7, 8. Got it. Any doubt? Anyone?
So far, it's good.
Okay. So coming to interview, you will explain, for example, the interview asks, give me the brief introduction about Kubernetes architecture. This is architecture. We need to explain with all components inside the Kubernetes cluster, starting with API, etcd, controller, scheduler. I will send the notes for the components, okay? Then coming to worker part, these are the things like node, pod, containers, application. Then how the worker part interact with the master part using which service?
Sorry, can you
How
repeat
the
the question?
how the nodes, okay, interact with the master part using which service?
API server, right?
No. From the nodes.
Controller, from the controller.
No. Leave the controller and scheduler. These are working only the
The
deployment part.
kube proxy will or kubelet will
Kubelet.
interact with
Actually, the
the
answer is kubelet.
kubelet. Yeah.
Kubelet is nothing. And there is that the agent sending the data to master part. Data means the resource data, the virtual machine data, how many nodes or pods, and not pods and containers, virtual machine, CPU, memory utilization, all the things sending to this way.
Okay.
Yeah. So if everything is fine, we can wind up. Any doubt?
I think it'll take a little time to digest these things.
Yes. So today it will, I think, someone face some difficult, right? Go through the when we
It's not
go.
difficult. It's like new terms are there, so to
Yes,
used to with
most
new terms it take
yes,
time.
most probably in Node. Coming to Node, the port, the container, like some confusing, right?
Yes.
Can you
No, it's
suggest?
just new to it. Not confusing
No.
necessarily. It's just
Okay.
new to it, right?
Right. New terms. That's why it will take time.
Yeah. Okay. Got it. So
If
tomorrow,
you
then we
if we
will
just wanted
create a
to,
managed cluster, and we will deploy an application. So you will get more idea. Okay.
Okay, sir. Shilpa was saying something.
Yeah.
yeah, I
Super.
just if we just have to go through this entire topic, not just this topic but the previous ones also, instead of the recordings, do we have any one place? Because I'm searching and I'm getting lot of links and YouTube links and other things. So do you suggest a specific uh, maybe a link or a site where we can go and just read it through?
Shilpa, I think there are previous batch recordings already available. You should have received a mail from these guys saying that AWS, let me call it out, AWS DevOps training links. Okay, if you haven't received that email, probably I can forward it to you, but they need to provide you the access to Google Docs. So if you have that, try to access it. If you get it, then fine, or else you can request them to give access.
Can you
Okay.
forward that email to me as well? I mean,
I
Yeah,
I also didn't get any mails
put it
like.
on the WhatsApp group or something. Might be easy. Everybody can see it.
yeah, I'll do that. I'll do that, guys.
Thanks.
Yeah, thank you.
If you want to drink from the fire hose, you can go directly to the Kubernetes project, right? Where Google created this and put it into the world.
I think
Yeah.
I haven't created it. Probably I'll have to start that. So let me do it in the WhatsApp first. Okay.
No. Like what I was saying is like if you want to drink from the fire hose, you can go directly to the Kubernetes project and study it from there. That's like the original right source.
Oh, what are these fire host and all?
Oh, the fire. That's just the expression. Drink from a fire hose. Lot of water comes out of it. You cannot drink. You will choke on it.
Yeah, got
That's the
that.
expression. Drinking
But
from a fire
I'm
hose.
just not talking about Kubernetes. I'm just in general the entire
Yeah.
course.
There is no
Wherever.
software called fire hose or anything.
Got that. Got
Shilpa, you can like in the YouTube, so many trainers are there who like sequentially in series wise. They have mentioned you can go through any of
Yeah,
the.
I've seen that. I'm
Mm.
just curious if there is any particular, instead of searching everything and going through half of something, going through half of some other thing, I'm just asking to suggest.
Right, right.
Everybody internalizes knowledge differently. So, giving it time and slowly digesting it in your own way, like somebody might explain it in a different way, right? So,
Yeah,
whoever's description sinks in with you, that's the person whose YouTube video you watch, right? I mean,
yeah, got
it
it.
might be different for everybody.
Meantime, I
Because
will share the notes, okay, for you. I didn't share
Okay.
notes, right?
No,
Yeah.
Yeah,
yes,
I
yes.
will update.
Because
guys,
these topics are like there is no head and tail, so it will be like it's not starting or
I
ending
like
any.
that. No head or tail, right? It's the
Right,
cloud.
cloud. It's like random. You need to go in any direction. It's
I think omelette is easier than kubelet, basically.
right.
guys, I shared the link in WhatsApp. If you guys can check it out if you have access. Or if you
Sure.
don't have access, then probably you can reach out to your HR, whoever contacted you or connected with you in the initial process, getting you into this course. They can help you out, giving you the access to this Google Doc.
You shared. Okay.
WhatsApp in
On the WhatsApp group.
Yeah,
training
we need
cloud
access.
AWS.
We need to request for access. Then we'll see.
Which one? Let me get my phone. I put my phone away to not be distracted during the lesson. Let me check my phone.
We need to raise a request for access. They have not given access for that Google sheet.
Okay.
So
Yeah,
Where
in
is
this
this
I mean,
Google
like
Sheet?
ideally,
links are given in
sorry.
the sheet in the Google sheet. Links are there for the
Yeah,
older
yeah,
video.
Yes,
Okay.
yeah.
yes. All are updated.
Oh,
Okay.
Docs Google Sheet.
Do
So,
you want
sir,
me to share the screen
the,
if you guys want to see what is there, what is in there?
it will be fine. Sir, these links, like you were the instructor for this last batch also.
Yes.
Okay.
Last batch was just me and sir.
Oh, so it was full. You completed the full course.
Not
We sort of,
not
not
Amol.
really.
Amol, that won't send to the team, the recording
Yeah,
section.
no, that wasn't recorded or anything. That was because there were not that many people were there, so it didn't become a real classroom. Like this one.
Oh,
It was just the
Okay.
New Year season and a Christmas season, and
oh, okay, okay,
so it
Yes.
didn't click basically.
okay.
The link listed in the shared file means, I mean, the first batch. Yeah.
Yeah, batch one. That's what it's listed in there.
Yes.
So it must be the batch one, not the batch with you, Amo.
No. Oh, I started the batch for the Guru School. So the first batch is that. Currently, we are in the second batch actually. In
Okay,
between, I mean, Amol and I started the sections, and
So
okay.
yeah.
was I the zeroth batch? Like they start counting the array from.
Yes.
You are the
And I was
mid
like,
between one and
I was
second.
the pointer arithmetic was wrong somewhere. So that was my batch.
Yeah, yeah.
Yes. So, yeah, coming to lab, you all get more idea, okay? If anyone face any doubt or anything in our current section, no worry about that.
Okay, sir. And sir, is the issue resolved regarding upload of the
No, the
video?
issue actually, I am using my corporate machine, okay? That's the reason. Sometimes they are blocking, but sometimes it's, see here, this is my Google Drive. See, but it's blocked my, but sometimes I can access, sometimes it's
Okay.
blocked. That's the reason from my side. Then I will upload, if I clear the issue, then I will upload to the drive. Then I send to the,
All you need to do is that, Tawfiq, all you need to do is like walk into any internet center or access your Google Gmail and then upload it from there. That's all. It's all done. Don't wait for to get the access, because this is not going to uh, solve your problem, because this is at the corporate level, right? They'll be surely blocking.
no, sometimes, for the recordings, I send several recordings, right? All recordings I upload from this machine. But
Are
recently,
you connected through a VPN?
no. Because in my previous project, I have a VPN, that perimeter VPN. But this project, I don't have a VPN. That's main thing actually.
Yeah.
Let's not get Tawfiq kicked out of his job because he tries to do something for Guru Schools.
Yes. Yeah.
But like Krishna said, there is more than one way to do something. So if there is a easier way for you to not get stuck behind a corporate firewall, maybe there is, you know.
It's very simple. I mean, like you just have to walk into any. I mean, like go to a friend's machine or any other machine, access your Gmail, all done. That's it.
But these are stored in his
Yes.
like
These are stored
laptop,
in,
right?
the previous recording is stored in my machine. So there is no way
Yeah.
Machine.
to getting this
Yeah.
data from this machine to another machine. That's the main thing. I didn't even plug it the pen drive, because that's all blocked from the corporate.
So can't you change the machine from for the coming at least for the coming session?
Yes, I plan to, because now I am staying in remote place near to
Right.
my office. That's the reason. My laptop's in my hometown, so I need to go to
Okay.
home and pick up the laptop, or else
Okay.
I will go with some VPN. Okay, one of my friend have VPN. He is my colleague, so I use.
Yeah. If you use VPN, you'll be able to access, because that's how I do.
Sure. Okay, I will try it today. Okay, to getting the VPN credential and uploading the videos.
Okay, sir.
Meantime, you can
Yeah.
go to the previous video. Okay.
Okay. Okay. Okay. So is
Thank-
it done for today?
Yeah.
Okay. Thank you. Thank you, sir. Thank
Yeah.
you,
Thank you.
everyone.
Bye
Good
all.
day.
Thank
Good
you.
night.
Good day.
Bye.
Good night. Bye.